Hello wonderful person, this is Anton, and in today's video we're going to do something a little bit silly. We're going to take a look at the newly added Tesla Roadster in Universe Sandbox Square, and then we're going to do something silly to it. We're going to turn it into a very massive object and basically create a super massive black hole using this weird car in space. Anyway, welcome to What the Math. So, what exactly are we going to be doing? We're going to modify Tesla Roadster's mass and its density and its size and turn it into something that will basically first eat up the solar system, and then we're going to go ahead and possibly even do a little bit more and maybe turn it into some sort of a supermassive black hole. Let's start by basically seeing what happens if you start increasing the mass of this object. And as you can probably imagine, with the increase in mass, the size of the object increases as well. Now, I want to start basically doing this until it just starts causing tremendous havoc on our solar system. This is obviously not the most scientific concept I could explore, but the reason I'm doing this is because I really wanted to show you that you can essentially turn pretty much anything into a black hole. A black hole is actually not something that is dependent on the mass as much as it is on the density. Now, to create a stable black hole though, you do need to have a lot of mass. Alright, so we're in kilograms now. Let's actually just go ahead and give it like one mass of the moon right away, and boom, look at that. It's a Tesla Roadster that's approximately 7,500 kilometers in radius. It can have its own Tesla Roadster orbiting around it. And why wouldn't it? Why wouldn't it? Because of course it would. So look at that. It's a Tesla Roadster system? Planetary system? I don't even know. It's a system of cars where two cars are orbiting around one another. Anyway, moving on with our mass addition, let's keep increasing this. Now, the density here is actually still pretty low. I may actually start decreasing this. Although it doesn't seem to... Oops, wrong way. It doesn't seem to be affecting the car that much just yet, but I want to actually make this mass much higher first before we start doing anything else to it. So right now this car is actually bigger in radius than our planet Earth. If I were to compare this to our beautiful planet, you would see that it's just a little bit bigger. But mass-wise, it's not. Mass-wise, it's actually significantly smaller, like 80 times smaller. So technically speaking, we could actually crash this into Earth, and it would probably cause us a lot of damage, but it wouldn't really be anything that impressive just yet. This is going to be a topic for another video. Right now, we're just going to increase its mass until it becomes an Earth-like object, bigger than Earth, mass of Earth. All right, so let's start increasing its density to the point where I actually want it to be density of water. So this right now is basically an ice-like object, 1 gram per centimeter cube. To make this into more of a Earth-like object, we have to change this into 5.5. So this would be an Earth-like object, size of Earth, mass of Earth, and pretty much density of Earth as well. And now we can start making this even more dense. So as a matter of fact, now that I have almost reached the mass of Earth, here we go, we're going to now change this into essentially a black hole-like object by reducing its size and increasing its density to the point where it's practically almost the same size as it used to be, but it's going to be tremendously dense. And this will actually be something that will indicate to us that it's slowly becoming more and more like a black hole. So here I have to increase my density to the point where it is basically around the same size as it used to be. Now here I have to be careful because I don't want the escape velocity to become speed of light, because that's when it becomes a essentially a black hole. The original car was what, like maybe 3 meters in radius, maybe 4. I'm not entirely sure actually. But even at this density, which is already a very, very high number, and at the mass of Earth, and only about 4 meters in radius, it's still not exactly a black hole just yet. So we actually have to change the escape velocity by a factor of about 20, I think. It has to become 20 times higher before it reaches the point where it is a black hole. Now I'm going to start increasing my mass again. And we're going to give it, let's just say 10 masses of Earth. Okay, well, maybe a little bit more. Let's actually make it very, very similar to Jupiter in mass. And at this point, its radius is about 27 meters. It is mass of Jupiter, so it's actually going to start attracting our planet Earth very, very soon, wherever that planet is right now. Oh, it already is. Look at that. And the moon is very fastly moving toward us, and so is the Earth actually. So we expect a collision from our moon relatively soon. But this is not the end yet. We're going to keep going and going and going until basically we reach mass that's even higher than this. Let's go for like practically 1% the mass of Sun. So at this point, even though our escape velocity is already very, very close to the escape velocity of a black hole, our mass and our radius... Oh, looks like something just collided with me. Anyway, so I accidentally pressed the wrong button, but I'm going to go back to 10 meters Tesla Roadster, and it is currently at the mass of 1% of the mass of the Sun. It has now reached the escape velocity of, I think it's 1/10 of the speed of light. So we need to actually give it a little bit less radius to give it a little bit more escape velocity. Now here, I think if I give it about like, what, 5 meters, and also maybe increase the mass a little bit more. Actually, it went the wrong way. I wanted it to increase, not decrease. Oh, look at that. Here we go. At 1% of mass of Sun, and also at 34 meters of radius, we get almost the escape velocity of the speed of light. And all of this implies that this is almost a black hole. Essentially, if I were to increase the density just a little bit more, it would become a black hole. And we can do this by, let's just increase the mass just a little bit more. And keep the radius where it is. And right around here. Yep. Okay, a little bit more. I mean, a little bit less. Here we go. 1 speed of light. So this is a Tesla Roadster black hole. Now, it doesn't look like one, mostly because the simulation doesn't really create a black hole out of human-made objects. But for all intents and purposes, this is a black hole. As a matter of fact, if I were to move it closer to its actual size, it would be an even more powerful black hole. The current escape velocity is way, way higher than the speed of light. It's like 3.4 times higher than the speed of light. We're not done here yet, though. We're going to keep increasing the mass of this object. And we're also going to keep... Ooh, okay, that's not exactly what I wanted. We're going to keep turning it closer and closer to an object that's going to become a supermassive destroyer of our solar system. So here, I think what I'm going to do is I'm going to give it 1 mass of the Sun. It is now a tremendously powerful, tremendously dense object that is going to start attracting pretty much everything from its vicinity toward itself. So if I were to zoom out here and take a look at the trails, you would probably see that very, very soon, pretty much everything is going to start moving toward us. Now, I think it already swallowed the Earth. I didn't really see how that happened because I think it just happened way too fast. But a lot of these objects will start moving toward us now. Let's keep increasing the mass of this. Let's make it 10 masses of the Sun to make it a little bit more realistic as a black hole. And we're going to also increase its size as well, because I want it to be a somewhat realistic looking black hole. And well, it turns out, as I was playing around with numbers, I basically completely changed the solar system, and now everything is out of whack, and here is the sun basically flying toward us. Actually, it flew past us. Interesting. And I think a lot of other planets are also doing very, very interesting things. Now, my mission is not finished here yet. I actually, wow, look at the Mercury go. I wanted to see not just what happens if you turn Tesla into solar-sized black hole, but also what would happen if we essentially put it in the middle of the galaxy and then turn it into a large black hole as well. Now, this is kind of interesting. Look at what happened if I basically turn this into a black hole. No other collisions though, but things did kind of fly away and fly apart. Alright, so what I'm going to do now is I'm going to open this galactic simulation that actually has our sun right there in the middle, and we're going to place Tesla Roadster around it and once again increase its mass to the point where it can't really handle it anymore, just like it did in the last part. So this time though, we're going to go into like really, really large numbers. Right away, we're going to start with one mass of the sun and keep increasing it more and more and more. So right now the sun is actually in orbit around Tesla Roadster, but as things progress, it's going to acquire more and more mass of the sun and basically swallow the whole galaxy. Let's do this as 100 masses of the sun. And look at that, our spinning 100 mass sun Tesla Roadster is now going to be flying through the galaxy. Alright, so what I'm going to do is continuously increase its mass, and then we're going to observe the effects it has on the rest of the galaxy. And this time we're not going to worry too much about the actual radius, because it does seem to actually bug out the game sometimes. But we are going to increase its mass. And let's go into the thousands, while also increasing the speed of the simulation. So right now, this is actually what would be known as the medium-sized black hole, if it was a black hole, that is. Although it is technically not, so maybe we'll change its value so that it actually does become a black hole again. We'll increase the density just a little bit, but now I actually want to start increasing the mass even more. So at some point, also, I think it helps to increase the speed of the simulation a little bit, just so we can see stars moving around. At some point, things will start basically kind of clumping around the beautiful Tesla Roadster as it propels itself through the rest of the galaxy. So okay, there we go. This is beautiful. Look at that. We're flying through the galaxy. The simulation is right now at like 8,000 years per second. And so let's see what would actually happen to the rest of the galaxy if, by some unknown chance, the beautiful Elon Musk's Tesla Roadster became a supermassive black hole, much, much more massive than anything else we can imagine. So we're gonna go into the millions of mass of the sun. Right now it's about 25% the mass of the central supermassive black hole in the middle of Milky Way. And as this happens, you'll notice that, first of all, Sagittarius A is going to start moving toward us, and second of all, the other stars will start basically kind of moving around Tesla Roadster as well. And well, looks like even though I've increased the Tesla Roadster's mass to like ridiculous amounts, it still hasn't really done what I wanted it to do. Oh, maybe that's because it doesn't have the mass of the Milky Way yet. Let's do this. Yeah, there we go. Here we go. This is actually a little bit unrealistic because Sagittarius A star is not as massive as the whole Milky Way. But in this simulation it is. So if I were to make it if I were to make Tesla Roadster 4 times as massive as the Milky Way, then it would start attracting everything around it, right? There we go, look at that. It actually kicked out the Sagittarius A star out of the system. And this is beautiful because this right here is what I wanted to create for a long time. Now this was completely by accident, but this kind of shows you how some this kind of shows you how some galaxies actually lose their black holes. Now we've found at least one, and I've actually talked about it in one of the videos that I've made previously, and you can check it out on the channel. But basically, this is exactly the simulation I've been looking for a long time. When a much more massive black hole approaches a smaller black hole, it can actually completely kick it out of the system, and then the galaxy, which is still there, basically starts kind of getting a little bit bumpier and bumpier. It's kind of hard for me to zoom into it now because it's so far away, but basically it sort of starts expanding and becomes more fluffy, and one of the biggest galaxies that we have discovered is actually that. It's a galaxy with no supermassive black hole, and it's the largest galaxy because it lost its central black hole through a collision with another galaxy. And beautiful Tesla Roadster, without knowing anything about the simulation, was able to actually recreate this very, very cool event completely by accident. Anyway, that's all I wanted to show you in this video. I wanted to play around with the Tesla Roadster, create a black hole out of it, and just so it happens, it actually was able to simulate a very, very cool event and show us how galaxies actually lose their black holes. In this video, that's all I wanted to talk about, and if you've enjoyed it, don't forget to subscribe, don't forget to share this video, and come back tomorrow to learn something else. Before we finish though, let's actually see what would happen if you were to also explode this beautiful car that is already so ridiculous and massive that it completely transcends all boundaries. So what would happen if you exploded this car? I guess nothing? Oh, there we go. Look at that. Whoa, beautiful explosions. Anyway, I'll see you guys tomorrow. Space out. Bye-bye.